The National Electrical Code Handbook, specifically Article 700, addresses emergency systems. Article 700.12b states that emergency lighting shall be provided for all areas in which a person may be required to pass or work. This requirement is typically met by the emergency lighting already installed in a building. An inspector's concern about a relay failure in a lighting control panel leading to a circuit outage is understandable from a safety perspective. The NEC does not explicitly mandate emergency backup for lighting control panels. However, there are several ways to address this concern and ensure continued lighting functionality. Firstly, you could install a separate emergency lighting control panel. This provides redundant control, ensuring emergency lighting remains operational even if the primary lighting control panel fails. Secondly, you can use a lighting control system with multiple redundant communication pathways. This minimizes the impact of a single point of failure on the entire lighting system. Thirdly, installing a dedicated emergency lighting circuit. This circuit is independent of the regular lighting circuits and supplies power to emergency lighting fixtures if the lighting control panel or regular circuits fail. The decision of whether to implement these solutions may depend on the inspector's interpretation of the code, the specific design of the lighting system, and the risk assessment for the building. While the NEC doesn't explicitly demand emergency backup for lighting control panels when emergency lighting is already present, these solutions offer enhanced reliability. It is essential to note that local amendments to the NEC can exist. These amendments are modifications or additions to the NEC adopted by state or local jurisdictions. These changes become part of the electrical code enforced in that specific area. Because of this, it is important to always consult with the local authority having jurisdiction, which would be the electrical inspector. They are the ones that ultimately approve the electrical installations in the building. Firstly, an inspector may have specific interpretations or requirements based on local conditions or past experiences. Secondly, it's always beneficial to establish a clear line of communication with the inspector. Discuss any concerns or questions openly, and seek clarification on any points of disagreement. This can help to avoid misunderstandings and ensure that the installation meets the inspector's expectations. Thirdly, always document all communication with the inspector, including dates, times, and the specific points discussed. This documentation can be helpful in resolving any disputes that may arise later on. Fourthly, if you disagree with the inspector's interpretation of the code, you have the right to appeal their decision. The appeals process typically involves submitting a written appeal to a higher authority, such as the local building department or electrical board. Lastly, in the event of an appeal, it is important to present your case clearly and concisely with supporting documentation and code references. Be prepared to answer questions and defend your position. Remember that the goal is to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. Let's dive further into the technical aspects of backup power solutions for lighting control panels. When designing an emergency lighting system, one important consideration is the type of backup power source to use. Some common options include generators, uninterruptible power supplies or UPS systems, and battery backup systems. Generators are typically used for larger facilities where a longer duration of backup power is required. Generators can provide power for hours or even days, depending on the size of the fuel tank. However, generators can be expensive to install and maintain, and they require regular testing and maintenance to ensure that they are ready to operate when needed. UPS systems are designed to provide immediate backup power in the event of a power outage. UPS systems use batteries to provide power, and they can typically provide power for 15 to 30 minutes. UPS systems are often used to protect critical equipment, such as computers and servers, from data loss or damage during a power outage. Battery backup systems are a simpler and more cost-effective option for providing backup power to lighting control panels. Battery backup systems typically use sealed lead-acid batteries, and they can provide power for several hours, depending on the size of the battery. When selecting a battery backup system, it is important to choose a system that is specifically designed for use with lighting control panels. These systems typically include features such as automatic battery charging, low voltage disconnect, and overcurrent protection. Another important consideration when designing an emergency lighting system is the type of lighting fixtures to use. Emergency lighting fixtures should be designed to provide adequate illumination in the event of a power outage. They should also be designed to operate on backup power. Some common types of emergency lighting fixtures include LED lighting fixtures, fluorescent lighting fixtures, and incandescent lighting fixtures. LED lighting fixtures are becoming increasingly popular for emergency lighting applications. LED lighting fixtures are energy efficient, long-lasting, and provide excellent illumination. Fluorescent lighting fixtures are another popular option for emergency lighting applications. Fluorescent lighting fixtures are more energy efficient than incandescent lighting fixtures, and they provide good illumination. Incandescent lighting fixtures are the least energy efficient option for emergency lighting applications. However, incandescent lighting fixtures are relatively inexpensive, and they provide a warm, inviting light. When selecting emergency lighting fixtures, it is important to choose fixtures that are listed for emergency use. These fixtures have been tested and certified to meet the requirements of the NEC. Another important consideration when designing an emergency lighting system is the location of the emergency lighting fixtures. Emergency lighting fixtures should be located in the areas where people may need to evacuate the building in the event of a power outage. Some common locations for emergency lighting fixtures include hallways, stairwells, exits, and assembly areas. Emergency lighting fixtures should also be located in areas where critical equipment is located, such as electrical rooms, mechanical rooms, and telecommunications rooms. The NEC provides specific requirements for the location of emergency lighting fixtures. Article 700.16 of the NEC requires that emergency lighting fixtures be arranged to provide illumination that is reasonably uniform and avoid shadows. The NEC also requires that emergency lighting fixtures be located so that they are not obstructed by doors or other objects. In addition to the NEC requirements, local building codes may also have specific requirements for the location of emergency lighting fixtures. It is important to consult with the local building department to ensure that the emergency lighting system meets all applicable codes and regulations. Once the emergency lighting system has been installed, it is important to test and maintain the system regularly. The NEC requires that emergency lighting systems be tested monthly and annually. Monthly testing involves verifying that the emergency lighting fixtures are operating properly and that the batteries are fully charged. Annual testing involves performing a more comprehensive test of the emergency lighting system, including verifying that the system can provide power for the required duration. The NEC also requires that emergency lighting systems be maintained in accordance with the manufacturer's instructions. This includes replacing batteries as needed and keeping the lighting fixtures clean and free of obstructions. Remember that electrical codes and their interpretations can vary. Here's a more detailed breakdown of how the NEC interacts with emergency lighting systems and potential areas of contention. Emergency systems fall under Article 700. As previously mentioned, it primarily focuses on life safety. It outlines requirements for power sources, transfer switches, circuit wiring, and illumination levels to ensure essential lighting remains functional during a power outage. Key requirements detailed under Article 700 include independent power sources, such as generators or batteries, that are separate from the normal electrical supply. These sources must have sufficient capacity and reliability to power the emergency lighting for a specified duration, usually 90 minutes to 2 hours depending on the application. Transfer switches automatically switch the load from the normal power source to the emergency power source when a power outage occurs. These switches must be reliable and capable of transferring the load within a specified time frame, typically within 10 seconds. Emergency lighting circuits must be independent of normal lighting circuits and must be protected from overcurrent and ground faults. The wiring for emergency circuits must be clearly identified and separated from other wiring. Illumination levels must meet minimum requirements to provide adequate visibility for egress and essential operations. The specific illumination levels vary depending on the occupancy and the tasks being performed. A potential point of contention could arise from the definition of areas requiring emergency lighting. While the code states areas in which a person may be required to pass or work, the interpretation of this phrase can be subjective. An inspector might argue that a specific area requires emergency lighting due to its potential use, while the building owner might disagree. In such cases, a risk assessment can be helpful. This assessment should consider the occupancy, the potential hazards, and the likelihood of a power outage. The results of the risk assessment can be used to justify the need for, or lack of need for, emergency lighting in a specific area. Another area of contention can be the type of emergency lighting fixtures used. The NEC requires that emergency lighting fixtures be listed for emergency use. This means that the fixtures have been tested and certified to meet the requirements of the NEC. However, there are many different types of emergency lighting fixtures available, and some may be more suitable for specific applications than others. For example, LED lighting fixtures are becoming increasingly popular for emergency lighting applications due to their energy efficiency and long lifespan. However, LED fixtures may not be suitable for all applications, such as areas where a high level of illumination is required. In such cases, fluorescent or incandescent fixtures may be a better option. The key is to select fixtures that provide adequate illumination, are reliable, and meet the requirements of the NEC. The maintenance and testing of emergency lighting systems can also be a source of disagreement. The NEC requires that emergency lighting systems be tested monthly and annually. However, the specific procedures for testing and maintenance are not always clear. To avoid disagreements, it is important to develop a detailed maintenance and testing plan that meets the requirements of the NEC and the manufacturer's instructions. The plan should include specific procedures for testing the system, inspecting the batteries, and replacing any worn or damaged components. It is also important to keep accurate records of all testing and maintenance activities. If a lighting control panel failure is a concern, several approaches beyond full emergency backup can enhance system resilience. Firstly, consider network redundancy. If the lighting control system uses a network for communication, implementing a redundant network architecture can prevent a single point of failure from disabling the entire system. This typically involves having two or more network paths between devices, so that if one path fails, the system can automatically switch to another path. Secondly, you could use a dual power supply. Power supply failures are a common cause of control system outages. Using a control panel with dual power supplies allows the system to continue operating even if one power supply fails. The power supplies should be connected to separate circuits to prevent a single circuit breaker from disabling both power supplies. Thirdly, there are bypass switches. Installing bypass switches allows you to manually override the control system and turn on the lights in the event of a system failure. This can be a simple and cost-effective way to provide a backup lighting solution. Fourthly, modular design is something to look at. Choosing a lighting control system with a modular design allows you to easily replace faulty components without having to replace the entire system. This can reduce downtime and maintenance costs. Finally, surge protection is crucial. Installing surge protection devices can protect the lighting control system from damage caused by power surges. Power surges can damage electronic components and cause system failures. Surge protection devices should be installed at the main electrical panel and at each lighting control panel. Furthermore, consider these additional details regarding the electrical inspector's concerns about relay failure and the potential for addressing it without resorting to a full emergency backup system. Let's consider the reliability of modern lighting control systems. Contemporary lighting control systems often incorporate highly reliable components and self-diagnostic features. Presenting data on the mean time between failures, or MTBF, for critical relays or modules within the system can help alleviate concerns. This data demonstrates the system's inherent robustness and low probability of failure. Also, Many advanced lighting control systems offer sophisticated monitoring and diagnostic capabilities. They can detect and report potential issues, including relay degradation or communication failures, before they lead to complete system outages. Highlighting these features can demonstrate a proactive approach to system maintenance and minimize the risk of unexpected failures. Furthermore, using addressable lighting control systems adds a layer of flexibility. These systems allow for individual control and monitoring of each lighting fixture. If a relay or module fails, only the affected fixture or zone will be impacted, minimizing the disruption to the overall lighting scheme. This targeted approach can be a more efficient and cost-effective solution compared to providing emergency backup for the entire system. Another option to explore would be a reduced voltage lighting system. These lighting control systems use lower voltages, such as 24 volts DC, for control signals. This reduces the risk of electrical shock and can improve the safety of the system. The lower voltages can make it simpler to integrate with battery backup systems or other emergency power sources. Ultimately, a well-documented maintenance plan is crucial. A comprehensive maintenance plan, including regular inspections, testing, and component replacements, can demonstrate a commitment to system reliability and minimize the risk of failures. The maintenance plan should be tailored to the specific lighting control system and the operating environment. When dealing with electrical inspectors, it is always helpful to have a clear understanding of the applicable codes and standards. The NEC provides specific requirements for emergency lighting systems, and it is important to ensure that the lighting control system meets these requirements. Furthermore, communication is key. Open and honest communication with the electrical inspector can help to resolve any concerns and ensure that the lighting control system is installed safely and correctly. Be prepared to discuss the design of the system, the components that are being used, and the measures that are being taken to ensure its reliability. If the electrical inspector has specific concerns, be prepared to address them in a timely and professional manner. Remember that the goal is to ensure that the lighting control system is safe and compliant with all applicable codes and standards. Consider the implications of battery backup systems for lighting control panels, as mentioned previously. The size and type of battery required depend on the load and the desired runtime. Sealed lead-acid batteries are commonly used, but lithium-ion batteries offer higher energy density and longer lifespans. The charger should be sized appropriately for the battery and should provide temperature compensation to maximize battery life. The transfer switch should be rated for the load and should switch automatically to battery power upon loss of normal power. The system should be tested regularly to ensure that the batteries are in good condition and that the transfer switch is functioning properly. Also, the NEC has specific requirements for emergency lighting systems. These requirements include minimum illumination levels, maximum transfer times, and testing and maintenance procedures. It is important to consult the NEC to ensure that the battery backup system meets all applicable requirements. In addition to the NEC requirements, local building codes may also have specific requirements for emergency lighting systems. It is important to consult with the local building department to ensure that the battery backup system meets all applicable codes and regulations. Finally, consider the life cycle costs of the battery backup system. The batteries will need to be replaced periodically, and the system will require regular maintenance. It is important to factor these costs into the overall cost of the system. If the building is equipped with a generator for emergency power, the generator can be used to power the lighting control panel in the event of a power outage. This eliminates the need for a separate battery backup system. However, the generator must be sized appropriately to handle the load of the lighting control panel. The transfer switch should be designed to switch automatically to generator power upon loss of normal power. The system should be tested regularly to ensure that the generator is functioning properly and that the transfer switch is operating correctly. The generator must be located in a well-ventilated area and must be equipped with a fuel supply that is sufficient to power the lighting control panel for the required runtime. The generator must be maintained in accordance with the manufacturer's instructions. Another alternative would be a hybrid system. A hybrid system combines a generator and a battery backup system. The generator provides backup power for extended outages, while the battery backup system provides backup power for short outages or during the time it takes for the generator to start. This approach combines the benefits of both systems and provides a reliable and cost-effective solution. The transfer switch should be designed to switch automatically to battery power upon loss of normal power and then to generator power after a short delay. The system should be tested regularly to ensure that both the generator and the battery backup system are functioning properly. The battery backup system can be sized to provide backup power for a shorter duration, which reduces the cost of the batteries. The generator can be sized to handle the load of the lighting control panel and other essential loads. In conclusion, while the electrical inspector's concern about relay failure is valid, there are several ways to address it without resorting to a full emergency backup system. Modern lighting control systems are reliable and offer self-diagnostic features, addressable control, and redundant communication pathways. A well-documented maintenance plan and open communication with the electrical inspector can help to ensure that the lighting control system is installed safely and correctly.